In this video, we're going to talk about trigonometric ratios. Most of us may be familiar with a right triangle from, let's say, geometry or so. Well, just to give a quick refresher, a right triangle, we know the longer side or the longest side would be our hypotenuse. So I'm going to put hypo for hypotenuse. And then the other two are just going to be your sides, right? But when we talk about trigonometric ratios, we're going to establish or point out a angle. And so we can use t. Most times we see theta. So let's say this angle is theta. Now it's going to be important that we look at where theta is, because with a right triangle and our trigonometric ratio, there are two important sides. There are going to be your adjacent side and your opposite side. Now, when we talk about the adjacent side, that's going to be the side that's very close to theta or right beside theta, hence the word adjacent. So my adjacent side is going to be this. Now, the side that is opposite is going to be the side or the side that is facing my angle theta, directly opposite of it. So this is going to be my opposite side. Okay? Now, we have this acronym that we use to establish or to talk about the trigonometric ratios. SOHCAHTOA. So, ka. So this should be a. TOA. Now, SOHCAHTOA helps us to understand the trig ratios in that S represents sine. So if I'm looking for sine theta, and sine theta is going to be with respect to the angle in my right triangle. So sine theta, this O in SO stands for opposite. Okay? So it's going to be a ratio. So O meaning opposite over H, which my H is going to be my hypotenuse. So that's my sine theta with respect to this theta and my triangle. Now, cosine, the C is cosine. So cosine theta, based on ka, so ka, right? This is my adjacent, and we'll do ADJ for adjacent. My ratio of my adjacent side over my H is, again, hypotenuse, right? And then the last one, T is tan, okay? And so tan theta is going to be equal to what? Remember, os is for opposite over my adjacent. So these are going to be our trig ratios. Now, when we talk about trigonometric ratios, most times these come in handy when we are dealing with the unit circle, right? And so we've looked at the unit circle and we've derived the unit circle before. But let's look at the importance of this right triangle inside the unit circle as it relates to my different sides. So for instance, let's say I have a circle and I inscribe or right triangle. This time we're not going to give it a specific measurement or degree measure. I'm just going to have a theta inscribed in my circle, or an angle theta. Notice again that we mark this and we say, okay, well, this is the intersection, right? It's going to be an X and a Y coordinate for this intersection. And so with this intersection, we can actually represent this in the sense of our trig ratios, or in terms of sine and cosine. Okay? Now let's see how this makes sense. So for instance, if we recall the distance below here per se, right? So our distance at the bottom, and we call this the bottom leg, and this is going to be our adjacent side. This is representing x, right? That's going to be my x, and then the distance or my height. Let me grab my color here. Here we go. So my height is going to be represented by y. Now, when we, and this normally just clicks, right? So recall that my hypotenuse in my unit circle, recall unit means a radius of 1. So we just talked about the trigonometric ratios, right? We just looked at our ratios in terms of sine, cosine, and those type of things. Now, if we have this right triangle inscribed in our circle, and we are trying to identify what is x and y in terms of sine, cosine, and tan, if any, right? So now if we look here, let's apply the trig ratio, SOHCAHTOA, to our unit circle, but our triangle inscribed inside the unit circle. So sine of theta, again, this time we're looking at the unit circle. So sine of theta is going to be equal to, like we said, it's going to be the opposite side of theta, right? Divided by the hypotenuse. That's my sine of theta. Now, if I look at the triangle that I have inside my circle, the opposite side here is actually going to be y. So that means this is going to be y divided by the hypotenuse. Now, let's look at what this means. Well, our hypotenuse is actually 1. So I can actually put 1 here for my hypotenuse. So let's do that. And so I'm going to put y over 1, or y divided by 1. So again, this means that sine of theta is y divided by 1. But what does that mean for us? Well, y divided by 1 is just y. So in other words, sine of theta is equal to y. So if I wanted to come back up here, I could literally put, since they're equal, I can replace y with sine theta. Okay? So what this means for us, it means that the y coordinate for the intersection of our right triangles, right? Or yes, our right triangles or angles within the unit circle, that y coordinate is going to be representative of sine of that angle, or sine theta. And we can use a similar method. Now let's look at what cosine of theta would be. So cosine of theta, that's going to be, like we said here, for our cosine, it's going to be the adjacent side divided by the hypotenuse, right? The adjacent side divided by the hypotenuse. Now, my adjacent side in this sense, in my triangle inside the unit circle, the adjacent side is actually x, right? So that's going to be x. What is my hypotenuse? My hypotenuse, again, is 1. So cosine of theta is going to be x divided by 1, or we can say cosine of theta is equal to 1. I'm sorry, x. Okay? So if I were to go back up here and look at my my unit circle, I can now, just like I replaced y with sine, I can replace x with cosine of theta. So as we are building the unit circle, I know in the previous video, we looked at how we can derive the unit circle. Now, the important part here is to see when it comes to trigonometry and the unit circle, how do they connect? Well, our x coordinate plane is going to correspond to cosine of theta in our unit circle, or in our triangle that's inscribed in the unit circle. And y is going to be sine of theta. Okay. Now, in a similar way, we can also derive the tangent of theta. Now, what is that in response or in reference to all of this? So let's look at what tan means for us. So tangent of theta, or we'll say tan for short. Tan of theta, well, that's going to be equal to, well, we said in our TOA, so I like to go back to these acronyms. So we had SOHCAHTOA, and so TOA is opposite, right? Opposite over adjacent. Okay. Now my opposite side, again, I'm looking at my triangle inscribed in my circle. The opposite side is y, and the adjacent side is x. Now, if I were to go back to what we just came up with, we just came up with the fact that sine of theta is equal to y. And we also came up with the fact that cosine of theta is equal to x, right? That's what we said. So if I were to write tan of theta in terms of sine and cosine, well, that's going to be, well, since y is equal to sine theta, I can plug that in. So it's going to be sine of theta divided by cosine of theta. And that's going to be tan. Okay. And so these are the first 3 trigonometric functions / ratio that we're gonna need to know when it comes to our unit circle, or just really trigonometry in general. This is the heart of trigonometry when it comes to your trig ratios.